Welcome to the problem section for this chapter, Calculators and Trigonometric Functions of an Acute Angle. And again, we're going to do a number of problems, but I think each of them is going to be relatively quickly. So here, add 51 degrees, 55 minutes, plus 37 degrees, 45 minutes. We add the degrees and minutes separately, so 51 plus 37 is 88. Then 55 minutes plus 45 minutes is, of course, 100 minutes, and that rolls over. It's going to be 1 extra degree and 40 minutes. 1 extra degree because 60 minutes are in 1 degree. So it's actually going to be 89 degrees and 40 minutes. Let's see, 63 plus 24 is going to be 87. 38 plus 52 is 90. So it's going to be an extra degree and 30 seconds. In the meantime, I'm going to double check my answers with the book, and so far I'm okay. So 61 plus 45 is 106. 33 plus 16 is 49. 77 plus 23 is 100. 21 plus 16 is 37. So there we go. I'll scroll up a little bit here. Get to the next exercise. Subtract. So 76 minus 22 is 54. 24 minus 34, well, that's not quite working out, which means I have to take away 1 from the 54. So only 53, and then 24 minus 34 is the same as negative 10 or 50. So I borrowed 1 degree here, which is 60, and so it's actually 84 minus 34, which of course is 50. 89 minus 28 is 61. 38 minus 58, well, I have to borrow 1. So it's actually 98 minus 58, which of course is 40. And again, I'm going to double check myself here. Yep, so far I'm okay. 70 minus 30 is 40. 40 minus 50, I have to borrow 1. So 39, so it's actually 100 minus 50, which is 50. 80 minus 50 is 30. 50 minus 56, I have to borrow 1. So 110 minus 56 is 54. 29 degrees, 54 minutes. Convert to degrees and minutes. 35.4 degrees is going to be 35 degrees and 24 minutes. Why? Because the decimal degree of 0.4 is multiplied by 60 to come up with the minutes. 63.2 is going to be 63 degrees and 12 minutes. 0.2 times 60 is 12. Might take you a moment on the calculator. I teach math every day, so I'm very quick in doing mental computation. 60 times 0.2 is 12. 16.25 is going to be 16 degrees. And then 0.25, well, that's a quarter degree, so it's going to be 50 minutes. Again, 0.25 times 60. That's going to be 18 degrees and 45 minutes. Again, I better double check that. And that's the answers that the book has. Change the decimal degrees. Well, it's going to be 45 point something. So in this case, it would be 12 minutes divided by 60, which is 0.2. This one is going to be 74 point something. 18 minutes divided by 60 is 0.3. 62 point something. 36 divided by 60 is 0.6. And 21 point something, 48 minutes divided by 60 is 0.8. So 21.8 degrees. Again, I'm going to double check that here in the book, and indeed those are the correct answers. So I'm going to scroll down here quite a bit. There we go. Next exercise says use a calculator to find sine of 27.2 degrees. Round your answer to 4 places past the decimal point. As far as significant figures, I'm not sure if I want to agree to that because it should be actually 3 places past the decimal point. Oh well. Sine of 27.2 degrees, cosine of 82.9 degrees, and then cosine 24 degrees 30 minutes, sine 35 degrees 10 minutes. I'm going to do that all at once on the graph calculator so I don't have to go forth and back. So there we go. Alright, the first one said sine of 27.2 degrees, which should be, in the neighborhood of 0.5 actually. And it is 0.457. I'm going to write this down here on the side. As I said, I don't want to switch forth and back. For 0.4571, so that I can write them down later when I go back to Word. The next one is going to be cosine of 82.9 degrees. Should be relatively close to 0. Yep, 0.1236. So there we go. Alright, the first one said sine of 27.2 degrees, which should be, in the neighborhood of 0.5 actually. And it is 0.457. I'm going to write this down here on the side. As I said, I don't want to switch forth and back. For 0.4571, so that I can write them down later when I go back to Word. The next one is going to be cosine of 82.9 degrees. Should be relatively close to 0. Yep, 0.1236. 0.1236. Then it's going to be cosine of 24 degrees and 30 minutes, and you will see in just a moment that it's kind of tough to put in degrees and minutes, so I'm going to be lazy and I'm going to write 24.5 degrees now that I'm confident in converting them from decimal degrees to degrees and minutes. So 24.5 degrees should be in the neighborhood of 0.9. Indeed it is, 0.9. Let's see, how do I round here? 0.9100 when I'm done rounding. How did I know that? Well, cosine, how did I know that? It should be about 0.9. Well, cosine of 30 degrees we have memorized as 0.866, so cosine of 24 degrees should be a little bit larger than that. And the last one that I have here is going to be sine of 35 degrees and 10 minutes. The 10 minutes here is a little bit rough to divide by 60, so here I will actually show you how to type it in on the calculator. And as I said, it's going to be kind of cumbersome. So we're going to go to angle, now we have the degree sign, then we're going to put 10, and then we go back to angle, and we take the minute sign right there, parentheses. Should be in the neighborhood of, between 0.5 and 0.7, so roughly 0.6, I guess. Indeed it is, 0.5757. 0.575759. And rounded there will be 0.5760. Okay, now I'm going to go back to Word and type in my answers. So let's see what we get. 0.4571. 0.1236, and then we have 0.9100, notice that the 2 zeros are significant because it's set to 4 decimal place behind the decimal point, and then 0.5760. Okay, let's see. Find acute angles for the next exercises. And what I wrote here is included are my mental computation approximations. Gosh, that's a long one. All it means is that, you know, I plug this into my head and come up with an approximation. I just have to find the right page in the book in order to do that. Okay, so theta equals inverse cosine of 0.9770, and as I said, I'll do that in a little while on the calculator. That's a relatively large cosine, so it should be a relatively small angle, so roughly 0 degrees we will come up with. Sine 0.3971, well, it's going to be the inverse sine. I think I'm just going to copy everything here, and then this one is going to be inverse sine of 0.3971. 0.4, do I have that memorized? It's a little bit less than 0.5, so a little bit less than 30 degrees, oh, maybe 25 degrees. Once we plug it in on the calculator, we'll see how close I am with my estimates. Inverse tangent of 0.6873 is what we're supposed to do. That should be a little more than 30 degrees, so let's make it 35 degrees. I said I'm really just approximating with the numbers that we have memorized for cosine, sine, and tangent. Okay, inverse cosine of 0.5490, which is relatively close to 0.5, which should be around 60 degrees. Secant of, inverse secant of 1.0191. Well, that means what I have to determine is actually the inverse cosine of the reciprocal. So actually what I should write here would be as follows: the inverse cosine of the reciprocal. I'm going to open parentheses here. So there we go. Simply because, of course, secant equals the reciprocal of 1 over cosine theta. I'm going to copy a theta here, which is going to be 1 divided by 1.091, and then of course I have to take the inverse of that one. Let's see if I got this correctly. Okay, I have to think about this one here if I wrote this down correctly. 1 over cosine. Let's see, maybe I should make a comma there. This is not correct here. Oh, there we go. Let's see where my mistake is. Comma cosine theta equals 1 divided by that. There we go. And then I just have to put in the theta right there. There we go. So, and then what I come up with here is, well, some number close to 1, so that should be roughly 0 degrees, what we should come up with when we're done. Secant theta here, is that virtually the same number? Let me just check with the book that I wrote this down correctly. Yeah, it is actually. So it's pretty much going to be the same as this here, except the number just looks a little bit different. 801. And then we're going to plug in all this here except for the number. So it's going to be 801, 801, and we're going to come up with something close to 0 degrees. I better write this down for myself so I don't make a mistake when I go to the graphing calculator. Cosine, the inverse cosine of 1 over 1.081, and then for the other one as well. Okay, let's go to the graphing calculator and see what we come up with. Let's see. Okay, the first one was inverse cosine, so second cosine, of 0.9770. Enter, and the estimated we should come up with almost 0. Well, okay, relatively close. 12 degrees. Oh, I forgot, maybe I did estimate 10 degrees. Something like that, 0 or 10 degrees. It's relatively close to my estimate. We may want to double check that we're really in degrees and not in radians. In fact, we are in degrees. Okay, the next one is going to be inverse sine of 0.3971, and did I estimate something like 30 degrees or less, 25 degrees maybe? Oops, where's my mistake? Well, I did the sine, not the inverse sine. I'm supposed to do the inverse sine. Enter 23.4 degrees. I have to see, we're supposed to round to the nearest 10 of a degree. So on the first one, I'm going to write down 12.3 degrees. On this one, I'm going to write down 23.4 degrees. Okay. Then it says inverse tangent of 0.6873, and I forgot what my estimate was, in the neighborhood of, I guess I should have written it down. What was it, 30 degrees? No, 40 degrees, maybe 35 or so. In fact, 34.5 degrees. Inverse cosine of 0.5490, and my estimate was in the neighborhood of 60 degrees. In fact, that's 56.7 degrees. Okay. Inverse secant of 1.0191, and what we have to do is we have to do the inverse cosine of 1 divided by 1.0191, and I said that should be relatively close to 0, 11.1 degrees. It's tough to estimate that at for such small angles, so I'm a little bit off. Let's actually look if we come up with the original result, which means I'm going to take the cosine of 11.11 and then invert that, take the reciprocal of that, so I'm going to do cosine of 11.1103 maybe, enter, and then I take the reciprocal of that, and indeed, there it is, 1.019 rounded 1. which was the original number for the secant. And the last one we're going to come up with is going to be, let's see, I'm going to go back a few times so we don't have to retype the whole thing. It's virtually the same as this one here. 1.0801 enter 22.2 degrees. 22.2 degrees. I guess it was a little bit off on those small angles for my estimate. But then again, my estimates are still not completely off, but definitely in the neighborhood. That's what estimates are for, that we can visualize numbers. So the first one, we have 12.3 degrees. Oh, I think I need the degree sign there. Then we had 23.4 degrees. Of course, here my estimate was really close. Then we had 34.5 degrees, and again I had a really close estimate. And then we had 56.7 degrees with a really close estimate. And then here again, two where it was a little bit off, 0.1, and the other one, 22.2. Okay, I'm not gonna apologize for, and I was a little bit off at those. After all, these are just estimates. Okay, let's go to the next one, which is going to be basically the same, except that we're supposed to round them to the nearest minute as we write them down in degrees and minutes. So let's see, inverse cosine of 0.4112. So that's going to be in the neighborhood of 60 degrees, a little bit more actually, 65, maybe 70 degrees. This one here then is going to be the inverse sine of 0.9954, and that's going to be close to 1, which means it's going to be close to 90 degrees. I'll be careful here, 85 degrees. Cotangent of 5.5764, which is the same as 1 over the tangent of theta. So tangent theta is going to be 1 divided by that number. Here we go. And therefore, theta is going to be the cotangent, the inverse cotangent of that number. So let me see if I can write this down here. Inverse cotangent of 5.5764, which is then going to be the inverse tangent of 1 over 5.5764. My estimate here, this is roughly 0.2, the inverse tangent of 0.2. That's really small, really a wild guess, 10 degrees. Really kind of similar to the this last problem here is really kind of similar to this one here, so I'm just going to copy and paste. There should be an equal sign right there, and then this one is going to be, of course, 4.62. Whoops. 4.1 divided by 4.6252. That's kind of interesting. I almost wrote it as 1/4. And then, of course, the rest is going to look really the same here. With, of course, this number. So that's going to be like again, so a neighborhood of 0.2 or so, and again 10, 15 degrees maybe. I'm sure that I'm somewhat off for these small angles. Okay, I'm going to go to the graphing calculator, but this time I'm going to write down my estimates so I won't forget them. And we're supposed to write down the answer to the nearest minute. So let's see, 65, 85 is what I write down, 10 degrees for my estimate, and 15 degrees. They are not crucial, these estimates. I just like to do them to see that I'm actually using the right mode, that I use the correct functions on the calculator, and my estimate helps there, even though at times it's going to be a little bit off. Okay, let's go over there. Clear this, and get started. Inverse cosine of 0.4112. Enter. 65.71 degrees. That was pretty much right on, 65 degrees. However, they want to have that, or the problem wants to have that in degrees and minutes. So I go to second angle, and I use the DMS here, which means degrees, minutes, seconds conversion. And there we go, 65 degrees and 43 minutes. Of course, it's impossible for me to estimate the minutes here. I'm lucky if I get it within 5 degrees. So let's see, the next one is going to be inverse sine of 0.9954, and my estimate was 85 degrees. In fact, that is 84.50. And again, I do second angle DMS, and automatically use the last answer when we do this, when we access that function on the calculator. And it does 84 degrees and 30 minutes. Don't round this to 31 minutes because that 8 here is actually 8 seconds. It says 0.8 seconds, so that's rather small. It has to be more than 30 seconds in order to round up by 1. Okay, the next one is the inverse tangent of 1 over 5.5764 parentheses. Oh, this time I lucked out. I was pretty close to my estimate of 10 degrees. And again, we're going to do the conversion to decimal, to degrees, minutes, and seconds. And this time I'm going to do second entry, and it gets back the same line. There we go. Here it's going to be 10 degrees, and then it rounds up to 10 minutes because there are 59 seconds in there. So 10 degrees, 10 minutes. Just to double check, the tangent of this angle. Oops, that's what I meant to do. I'll try this again. The tangent of this angle, which is the answer of this one here, comes out to 0.179, and when we take the reciprocal of that, which is the cotangent, and we come up with the original 5.5764. Okay, the last one is going to be inverse tangent of 1 divided by 4.6252 parentheses, enter 12 point something degrees. My estimate was 15 degrees. Notice that my learning curve went up compared to the last exercises where my estimates are a little closer. Now, okay, second angle, convert to degrees, minutes, seconds, 12 degrees and 12 minutes rounded. Okay, going back to Word. So let's see, this one was 65 and 43. This one was 84 and 30. this one 10 and 10. See, there it is, 10, 10. Looks a little bit better putting on the next line. Probably do it with this one as well. So this one was 12 degrees and 12 minutes. Next one here goes relatively quickly. We're supposed to do this on the calculator. Of course, these are Pythagorean identities, so we'll type them in. Let's see. So we're going to have sine 37 degrees squared plus cosine 37 degrees squared. And indeed, the square here squares the whole sine of 37, not just the 37. And we come up with 1, just like it should be. Pythagorean identity. I'm going to use second entry here and then substitute 85 for both. 85. And of course I come up with 1. And going back to Word, and we're virtually done with this problem section. Both of these come out to 1.